Here is a real data example. Let's assume that you work for a company that wants to study the salary of the employees. You have a dataset in Excel with the salary for all 6,419 employees. Salary is a continuous quantitative variable. Since we have more than 6,000 observations, we need to convert continuous quantitative variable into intervals. Interval is a categorical variable, so we can have a better overview of this dataset. Here is how the dataset looks like. As we learned in Module 1, histogram is an efficient method to represent a continuous quantitative variable. Here, in this histogram, the green vertical line represents mean, and the red vertical line represents median. Since you have all the data, you decide to look at information about the entire population. So here are population parameter values. Mean is represented by this horizontal green line, and the median by definition equals to Q2. This is minimum. This is Q1. This is Q2, which equals median, as I just said. This is Q3, and this is maximum. Using software like StatCrunch, you can also calculate the standard deviation, range, and the interquartile range. Those are three measures to measure variability. Assume the company wasn't great at keeping up the salary database, so you have to go through paperwork to determine an employee's salary. You don't want to look at all employees' paperwork, so you are going to randomly sample 100 employees to review. Here is how sample 1 looks like. And here is how sample 2 may look like. As you may have noticed, the sample mean from 1 are not equal to sample mean from sample 2. This is actually what we expect, because we randomly assemble 100 employees to review. Other sample statistics like median, minimum, Q1, Q2, Q3 are all different from sample 1 and sample 2. So are variabilities between sample 1 and sample 2. Again, this is what we expect, since we randomly assemble 100 employees to review. From this side-by-side box plot, you can compare difference between population, sample 1 and sample 2.